A black hole once spat out a star like it was nothing. I know, that sounds wrong, because we picture black holes as one-way traps. You fall in, you stay in, and gone. A lot of people even think black holes suck things in like cosmic vacuums. They don't. They're not hungry monsters. They're just objects with strong gravity, and gravity doesn't work like a mouth, it works like a slope. If you're far enough away, you can walk off the slope with zero problem. If you get too close, you slip. If you get way too close, well, you stop existing. But here's what people miss. Black holes don't only pull things in, sometimes they fling things out. Hard, fast, violently. So fast that the galaxy can't hold on to them. And that's what happened with a star a few million years ago. Astronomers traced its path and realized the star didn't just wander into space on its own. Something kicked it so hard it's now flying out of the Milky Way at a speed you can't feel in your body or your mind. But the math doesn't lie. The kick came from our own supermassive black hole. The strangest part is this wasn't an explosion. It wasn't a blast. It was almost gentle, in a cosmic way. A weird piece of gravity math played out, and one star got locked in, while the other was launched away like a stone from a slingshot. To understand what happened, you don't need any fancy physics. You just need to picture the center of our galaxy. Buried there is Sagittarius A. It's not out there shredding stars every second. It just sits in the middle like a heavy boulder in a river. Space flows around it. Stars orbit it. Clouds drift past it. Now imagine two stars traveling together. Stars do that more often than you'd think. They're like dance partners that form together and stuck with each other. They orbit a shared center, moving as a pair through the galaxy. Usually they don't cause trouble, they just exist. But sometimes, that pair drifts a little too close to the danger zone around Sagittarius A. Not close enough to fall inside, but close enough to get caught in its gravitational grip. That's where things get messy. The moment a two-star system wanders into that region, it stops being a simple problem. It becomes something called a three-body problem. You have two stars playing tag with each other, and a black hole that's millions of times heavier than both of them combined. The black hole doesn't politely watch from the side, it pulls, it stretches, it throws off their balance. One star gets pulled in harder than the other. The pair breaks, and once the pair breaks, everything happens fast. Sagittarius A drags one star into a tight orbit. It doesn't swallow it, it just keeps it. But the other star doesn't get the same treatment. All the momentum gets shoved into the remaining partner, and that star gets shot outward at unbelievable speed. It's like you and a friend walking near a deep pit. Suddenly, someone pulls your friend toward the pit. Instinctively, your friend grabs your arm. Your friend's body moves toward the danger. Because they're holding your hand, their movement pulls you too. But instead of both of you falling in, something different happens. Your friend's whole weight pulls their arm out of your hand. When that happens, all the force they were putting on you suddenly stops. Your body snaps backward because you were resisting the pull a moment before. The difference is that a black hole doesn't grab. It uses the natural pull of gravity to do the same thing, but at a scale your body can't relate to. The star that got flung away becomes what astronomers call a hypervelocity star. That's exactly what it sounds like. A star moving so fast that nothing in the galaxy can grab it back. Not the spiral arms, not the galactic gravity well, not even the dark matter halo wrapped around us. Once a star reaches that speed, it's gone. Forever. The Milky Way can't slow it down. It can't pull it back. It's like a baseball thrown so hard it escapes Earth's gravity and never comes back down. The star didn't just hit that speed, it shattered that boundary. When astronomers spotted it, they measured its speed at around 6 million kilometers per hour. Not fast for a star, fast, period. That speed means it covers the distance from New York to Los Angeles in the time it takes you to blink. And the only thing powerful enough to give a star that kind of kick is a supermassive black hole. Nothing else comes close. When researchers traced its path backward, all arrows pointed to Sagittarius A. The star came straight from the center of our galaxy. Not from a cluster, not from a random explosion. It came from the place where the gravity is strongest. And the timing lines up with the classic three-body interaction that breaks up binary star systems. This is where the spit-out idea comes from. The star never went inside the black hole. Nothing ever comes out from inside. But the way the star was thrown was so fast and so clean that it feels like it was ejected. And the math says the black hole punted this thing straight out of the galaxy. The wild part is how ordinary this event is for the universe. It's rare for us to see, but it's not rare for the cosmos to do. Black holes launch stars every so often, and those stars spend billions of years drifting through empty space. They don't orbit anything, they don't belong to any galaxy. They're homeless, not by choice, but because gravity gave them one final shove too strong to resist. By the time astronomers confirmed the star's speed and traced its path, the whole thing was already bigger than one dramatic moment near a black hole. Because once you understand what actually happened, you start seeing how much this one event says about the way the universe works. And the funny thing is, none of it requires complicated equations. It's just gravity doing what gravity does when things wander too close to something that outweighs them by millions of times. What makes this even more interesting is how clean the ejection was. You'd expect chaos. You'd picture a star ripped apart or bent out of shape. But stars are tougher than people think. They're not fragile candles floating in space. They're massive, dense balls of hot gas held together by their own gravity. So when one gets slingshotted away, it doesn't tear apart. It just keeps moving, carrying all its heat and mass and fuel with it like nothing happened. The moment the star broke free, it was no longer part of the Milky Way in any real sense. Sure, it started here, it was born here, it orbited here, but the instant it crossed the escape velocity of the galaxy, it became a traveler, a runaway, a future resident of nowhere, and it will keep going for billions of years until the universe gets too stretched out to hold on to anything. People think galaxies are static, peaceful islands of stars slowly spinning in place. They're not. They're active. They're messy. They're constantly losing stars, gaining stars, merging, stretching, and changing shape. Black holes might sit in the center, but they influence everything. Their gravity sculpts orbits, collapses clouds, and flings out anything that gets caught in the wrong kind of gravitational dance. And the star we're talking about, S5HVS1, is one of the clearest examples. Once the black hole captured its partner, this one had no choice. The breakup of the binary dumped energy into it like a spring snapping open. That energy became velocity. That velocity became freedom. And now the star is sprinting through the galaxy halo like it's trying to catch a train that left millions of years ago. Even calling it a kick doesn't capture the scale. It's like comparing a sneeze to a hurricane. The force that launched this star wasn't a push. It was gravity rerouting the momentum of an entire system. And while it looks dramatic to us, for the black hole, it was just Tuesday. These events have probably happened countless times around Sagittarius A. We only noticed this one because it happened in a direction we could track. Hypervelocity stars change what we understand about how galaxies interact. If a star is moving fast enough, it might leave the galaxy completely and drift into the empty space between galaxies. That's a place with almost nothing. No gas, no neighbors, no gravity wells pulling it back in. Just loneliness on a scale that's hard to imagine. Every star that leaves shifts the distribution of mass, even slightly. It changes how the galaxy spins, how it evolves, how it responds to incoming material. These high-speed ejects are rare, but over billions of years, even rare events add up. They shape our galaxy just like collisions, star births, and supernovae do. Of course, we need to clear up the biggest misunderstanding before going any further. The star didn't escape from inside the black hole. Nothing leaves a black hole once it's inside the event horizon. That's final. No exceptions, no, but maybe. The dramatic language spat out, thrown, launched refers to what happened outside the event horizon. The star was never swallowed. It never crossed the point of no return. The black hole only grabbed its partner and used the broken orbit to hurl the second star away. So when people imagine a black hole gulping something down and then spitting it out like a bad snack, that's not what happened. What happened is more like three kids on a trampoline. Two are bouncing near each other. The third is way heavier than both. The heavy one pulls one kid inward, the second kid gets flung outward with extra speed. Nothing supernatural, just gravity being gravity when things wander too close to something that outweighs them by millions of times. This shows black holes aren't just destroyers, they're engines. They rearrange the galaxy in ways you don't see until you zoom out far enough. They take in some things and throw out others. They change the structure of star clusters. They control the shape of the galaxy's center. And sometimes they launch a star so hard that the star becomes a cosmic exile.
It's also worth pointing out that these runaway stars aren't even rare in a cosmic sense. We've already found several. Some came from black holes, some came from supernova explosions, some came from close encounters with clusters. But the fastest ones, the ones that punch through the galaxy like darts, almost always point back to a massive gravitational source. And the fastest of all point back to Sagittarius A. When you look at that, this stops being about one star and becomes a reminder of how dynamic the universe is. Everything is in motion. Everything is interacting. The night sky you see is a picture of something that never stops moving, never stops changing, and never stops throwing surprises our way.
When you step back and look at everything this one runaway star tells you, the picture becomes even clearer. A black hole isn't some cosmic monster hiding in the dark. It's more like the anchor point of the whole galaxy. It shapes orbits, it stirs the center, and every once in a while, it throws something out with so much speed that the galaxy can't take it back. It's strange to think something so dark can change the future of something as huge as the Milky Way, but that's exactly what happens. Hypervelocity stars are like little reminders that nothing in the universe stays still. A star can spend its entire life orbiting peacefully, and then one wrong turn near the center sends it flying into the void forever. And that doesn't make the galaxy weaker or broken. It's simply part of how galaxies breathe. They lose some stars, they gain others, they grow, they twist, they collide with neighbors, and the black hole at the center helps shape the whole thing, whether it's feeding or not. If you were able to watch the Milky Way over billions of years like a time lapse, you'd see stars being born, stars exploding, stars drifting out of sight, and a few being fired off like tiny glowing bullets. That runaway star is out there right now, still racing away from us. It'll keep going long after the sun burns out, long after Earth stops existing, long after the galaxy changes shape. It won't slow down. Nothing is waiting for it out there. It'll shine into empty space until it runs out of fuel. And somehow, that makes the universe feel bigger and smaller at the same time. Bigger because events like this remind you how much power sits in the dark. Smaller because a single moment, two stars wandering too close, can send a ripple across millions of light years. So, the star wasn't inside the black hole. It didn't escape from the event horizon. Nothing escapes that. This whole thing happened outside, where gravity still follows the same rules you deal with on Earth, just at a scale your body isn't built to handle. Spat out is a human way of describing something that was really just momentum being handed off in the most dramatic way possible. A black hole didn't swallow everything around it. It changed the path of the universe in a single moment. And that star will spend its entire life showing us the direction it was pushed. If you walk outside tonight and look up, that runaway star won't be visible. It's too far and too faint. But it's there, still on its straight path through nowhere. And knowing that feels strangely honest. The universe isn't tidy, it's not gentle, but it's full of motion and surprises and small stories that stretch across millions of years. A black hole once spat out a star,